is the preparation from alcohol. So in the preparation from alcohol, the first method is by the action of halogen acid. Halogen acid is generally expressed as HX. For example, we have an alcohol and when we add halogen acid HX, it may be HCl, it may be HBr, it may be HI. It will give you the alkyl halide, like this OH gets replaced by X and water is produced. So order of is if we see this, then order of reactivity, that is HI, HBr, HC. That depends upon the bond association energy. So the alcohol, if you see about the order of reactivity of alcohol, then 3 degree alcohol is more reactive than 2 degree. 2 degree is more reactive than 1 degree. So some examples are, like first example is, suppose we have ethanol CH3 CH2 OH and we are adding a HCl gaseous state in the presence of anhydrous zinc chloride to form CH3, CH2, Cl and water. If we have a, say, isopropyl alcohol and we are adding the same reagent in the presence of anhydrous ZnCl2, it will give you isopropyl chloride. Very simple reaction. So when you take a 3 degree alcohol, say tetrabutyl, and we are adding HCl. Now there is no need of anhydrous zinc chloride because 3 degree is more reactive than 2, is more reactive than 1. Okay. Next is the combination, this HCl gas plus anhydrous chloride. This is called Lucas reagent. And this process of formation of alkyl halide is called Group's process. What is the role of anhydrous zinc chloride? Why it is used here? So ZnCl2 is a Lewis acid. It has a tendency to accept a pair of electrons. So it is electron deficient. So it coordinates with the lone pair of electron on the oxygen atom of alcohol, resulting in weakening of COH bond. So zinc chloride coordinate with lone pair of electron of alcohol, resulting weakening of OH bond. तो ये बॉन्ड जो है वो वीक हो जाएगा and it will break easily. Side by side you can say zinc chloride absorb water which is produced in the reaction. So you can say it has a two role because it is hygroscopic. One is it coordinates with oxygen because it's a Lewis acid which make easy the cleavage of COH bond. And second is it absorbs moisture which is formed during the reaction. So this is the first. If you see the mechanism of this reaction, first step is like if we have an alcohol, it coordinates with H to produce protonated alcohol. This protonated alcohol release water to produce carbocation. This carbocation then attacked by chloride ion to produce this alkyl halide. Next is by the action of phosphorus halide. So all the haloalkanes are prepared from alcohol. Phosphorus halides are of two types. One you can say is a PCl3, second we have a PCl5. So by both we can prepare the haloalkanes. For example, if we have ethyl alcohol, we are adding PCl5 to it. It will give you haloalkane. That is CH3, CH2Cl plus POCl, phosphorus oxychloride and HCl is produced. Now, same for the PCl3. Suppose we take a 3 mole of like isopropyl alcohol and adding PCl3 to it. Again, you get a 3 mole of isopropyl chloride here plus phosphorus acid is formed. So this was the simple easy preparation of alkyl halide from alcohol. Next C part is by the action of thionyl chloride. By the action of thionyl chloride. That is SOCl2. So thionyl chloride, that is called a Darson method. DARZEN, Darson method. So in this case, if we take ethyl alcohol, adding thionyl chloride, it immediately changes into this ethyl chloride plus SO2 gaseous form, HCl gaseous form is produced. So this reaction is preferred over the all other reactions. Suppose we want to prepare alkyl bromide by this method B. Chloride is prepared by PCl5 or PCl3. A PbR3 cannot be directly used. So for alkyl bromide, and iodides, what you do is take the red phosphorus, adding Br2. So this will give you PbR3. This PbR3 then react with an alcohol. Take 3 mole, adding phosphorus tribromide. That will give you a alkyl bromide. 3 mole of CH3, CH2Br along with phosphorus acid. Same for iodide. We have to add P4 plus 6I2. It will give you Pi3. Then we will add same ethyl alcohol plus Pi3 will give you 3 mole of iodide plus phosphorus acid. So now we have these methods to prepare. We summarize. Like we have alcohol, we added PCl5, we added PCl3, we added P plus Br2, we added P plus I2, we added SOCl2. In all cases we get alkyl halide. Like CH3, CH2, Cl here, CH3, Cl2, Cl here, CH3, CH2, Br here, CH3, Cl2, I here, CH2, Cl3, Cl here. And out of these simple methods of preparation of alkyl halide, we prefer this method. Preparation with SOCl2 is preferred. Why? Because side products like SO2 and HCl are gases. They escape and give and residue will be pure. That's why we prefer thionyl chloride process to prepare the alkyl halide. Okay. So these are the 3 methods from alcohol. Next, fourth is method is preparation by halide exchange method. Halide exchange means one halide replaced by the other. This reaction is called Finkelstein reaction. Okay. What happened in this case is, suppose we have a chloride. We added sodium iodide in the presence of acetone. Acetone is a common solvent, nothing else. So there is a halide exchange. This iodine replaces chlorine. So it becomes iodoketane. Suppose we have a bromo ethane. This can be replaced by sodium iodide in the presence of acetone. We get ido-NaBr. So these NaCl and NaBr are very little soluble in methyl alcohol or acetone, so they can be removed easily. Okay. Next, there is one more reaction that's also called halide exchange, and that's also Schwarz reaction. That also comes under the category of this halide exchange. What happened in Schwarz reaction is that if we have a methyl bromide and we are adding some fluorinating agent, AgF, okay, reflux in the presence of CCl4 and non-polar solvent. So this bromine gets replaced by fluorine. So this is called Schwarz reaction. This is also a halide exchange reaction. So here, you can say bromine gets replaced by fluorine. Otherwise, directly alkyl fluoride की preparation जो है that is tough मैंने बताया because this reaction is explosive reaction. Fifth point है जो इसमें and last है preparation from silver salt of fatty acid. Silver salt of fatty acids. That is called borodine. Hunsaker's reaction. Borodine Hunsaker reaction. So in this case we will take silver propioid, CH3COO, Ag. And we will add bromine in the presence of CCl2 or CCl4 solvent. You will get ethyl bromide. Carbon dioxide plus AgBr. So in this way we can prepare the alkyl halide also. So only boroalkanes and alkyl bromides are prepared by this method. And there is degrees of carbon length. यहाँ पे अगर 3 कार्बन है वहाँ पे first is only alkyl bromides can be prepared by this method. Second is product formed will be 1 carbon less than reactant. If we try it with the iodine, suppose we treat this silver salt of fatty acid with iodine. Because iodine की activity कम है, so it will not give you the alkyl halide. It will give you methyl ethanoate carbon dioxide. It will give you ester. Okay, plus carbon dioxide plus 2Gi. So this is ester. Ester is produced instead of alkyl halide. Ester is produced. This reaction is called Beerenbaum okay. simony reaction. Exact spelling are BAUM. Biranbaum simony reaction. This one. So that's all about the preparation of haloalkanes. The next lecture we will do the reactions of alkyl halide. That's very interesting reactions. So these are the 5 points are there in the preparation. And some binary reactions are also there, like Borody-Hunslicker reaction, Biranbaum-Simony reaction, Schwarz reaction, like that. So in the next lecture we will do the preparation, the chemical properties of haloalkanes.